Moving on with our next lesson for logarithms, solving logs. The last lesson we solved exponentials. That was a lesson we had to pay attention to. This is your second lesson. You're really going to have to pay attention to solving logarithms. So there's going to be logarithmic equations, not just exponential equations. We are going to solve logarithmic equations algebraically. And we're going to start off easy and slowly get more and more involved. Example 1, solve a and b. X could be in different spots. Right now, the x is in the argument spot. How do I figure out what x is? We've done these, or at least something like a, in a previous lesson. And it comes back to your fundamental understanding of what a logarithm is and how does it relate to an exponential. Well, my base is 6. I know that the answer to a logarithm is the exponent, so 6 to the exponent 2 equals x. Pretty straightforward. 6 squared equals x. What is 6 squared? 36. We just successfully solved for or determined what x was, which we've done in a previous lesson. Same idea for b, just kicks it up one little notch. My base is 2. My answer right here is the exponent. 2 to the 7 equals, this is my solution, x plus 5. What is 2 to the 7? 2 to the 7 is 128. X plus 5. Bring that 5 over, becomes negative. What's 128 minus 5? 123 equals x. And remember, just like we've been doing all along, you can sub those back into your equation, your original question, and make sure you get the right answer. Now, if you look at a, for instance, even though it's easy, you'd have log base 6 of 36. How do you do that? Well, don't forget, change your base. Log big number divided by log small number. So if you want to check, you could do log 36 divided by log 6. You should get 2. Same idea for b. Put 123 in for x. That's log in base 2 of 123 plus 5, which is 128. Change your base formula. Log of 128 divided by log 2 should be 7. Easy peasy, right? C and D. Still solving. Now you could, if you wanted to, change this to an exponential for C. Remember, when you don't see a base, that doesn't mean it's 0, it means it's 10. So technically we could say this is 10 to the exponent log x minus 7 equals 5, and do some log laws and rules and break it down that way. It would be a much more convoluted way to get to our right answer. Remember, when you're solving an equation, you just want left side equals right side. Well, I already have log on both sides. I know they're both the exact same base. So if you're playing match game, so to speak, this has to match that. That has to equal 5 has to equal x minus 7. Easy. Bring over the negative 7, becomes a positive 7. 5 plus 7 is 12. Perfect. D. So here's our first real challenge one, where we don't necessarily know what to do. First thing you have to identify, do they all have the same base? That answer is yes. They're all log 10, right? Common logarithm. To be able to solve this, you have to kind of take a look at this and remember one of your laws. So you have to remember that when you are adding, you can technically use the product law. So I have log of something plus log of something. I can use the product law, which if I'm adding, that means I can multiply the arguments. So log of x plus 2 times x minus 4, multiplying a binomial, n equals log 7. Just like last time, we could go through a convoluted process, but I have log and log. So this has to equal this. My binomial expansion has to equal 7. So x plus 2 and x minus 4 has to equal 7. FOIL, collect like terms. I'm going to cut to the chase here. I'm assuming we all know how to FOIL and collect like terms. You would get x squared minus 2x minus 8. Bring that 7 over, becomes minus 7 equal to 0. X squared minus 2x minus 15 equals 0. How do I solve that? How do I solve a quadratic? Got to find the zeros. How do I find the zeros? Factor, or you could use quadratic formula if you want to flex that skill. This is a simple trinomial to factor. X minus 5 and x plus 3. That means x equals 5 and x equals negative 3. Now you have to remember one thing here. Always take those x values and look back at your question. So let's try 5. If I put 5 into the first log, you get 7. Perfect. If I put 5 into the next log, I get 1. Fine, that works. Check. Negative 3. If I put that into the first log, negative 3 plus 2 is negative 1. Can't do that. Don't forget, if you think of your patterns or think of your graph, you can never find the log of a negative number. That doesn't mean x can't be negative. It means that when you put it back into your equation, you can't have a log of a negative. So just watch out for that. If by chance it was like x plus 4 and x plus 5, then yeah, negative 3 would still work, right? Because you still end up with positive numbers when you put the negative 3 in. In any event, we've already encountered x minus 3 does not work. So not a solution. Make sure on a test, you actually, if any of them or both of them don't work, make sure you tell me they're not a solution and tell me why. So not a solution, and then we can say, for example, if we use the first one, negative 3 plus 2, negative 1, and you can't do that. Running out of space there, but you would actually write, can't take the log of a negative number. So we only have one solution, x equals 5. E. Looks similar to the one we just did, except for it equals 1. We've kind of tackled this before. We want those to all be logarithms. So you have to remember that if I do log in base 6 of 6, that's just 1. So really this boils down to log in base 6 of x plus log in base 6 of x plus 1 equals log in base 6 of 6. Now just like the last question, I'm adding. The bases are the same. That means I can use product law. So log in base 6 of x times x plus 1 equals log in base 6 of 6. This is the same as that side. They're both log 6s. So all that means is this has got to equal this. X times x plus 1 has got to equal to 6. Distribute, bring the 6 over, collect like terms. You'd have x squared plus x minus 6 equals 0. Simple trinomial to factor. x plus 3, x minus 2. That means x equals negative 3, x equals 2. Make sure they work. 2 definitely works. We go back to our question. 2 plus 1 obviously is positive, and put a 2 in for the first x works. Negative 3, not a solution. And then we can say log in base 6, negative 3 does not work. Negative number. Now, I'm going to do a little aside here. Let's say, and this is going to happen for a lot of these questions. There's a lot of different ways you can do the logarithm and exponential questions. Let's say for a second, you forgot about this. You left it as 1, you didn't realize what to do. You could still do the product rule like you did on the left. And what would happen is, you would be at this step, log in base 6 of x times x plus 1 equals 1. You could convert that to an exponential. There's my base, there's my exponent, there's my answer. So I'd have 6 to the 1 equals x times x plus 1. That's just switching to exponential notation. And as you can see, it's the exact same as that. And you would just continue and get the exact same answer. Just something to keep in mind. Again, there's lots of different ways to do these questions. F. They don't have the same base. I can't use product law or anything like that on those. So maybe let's think about what happens if we convert this to an exponential. It's going to look weird, but log in base 13 of 497, that's just a number. It's a nasty number, but it's still a number. There's my base, 7. Remember, the answer to a logarithm is the exponent. So 7 to the log in base 13 of 497 equals x. Well, how do you do log in base 13? You can't. Your calculator can't do that. And if you do have a calculator that can do that, remember it's technically an illegal calculator and you still have to show me the work. Well, this is change of base then, right? So log of 497 divided by log of 13 is your entire exponent. So you enter that in just like that. You might want to consider entering the exponent in brackets. Go to 2 decimal places and tell me what you get. Hopefully you get 111.07 equals x. And you can sub that back into your original question and make sure you get left side equals right side when you do it. Roughly, since we approximated our answer. G. All right. So I've got addition. I've got subtraction. They're all the same base of logarithm, which is good. So this is going to be, there is product law, and that little bit of minus, don't forget, is quotient law. So log in base 4, product law means I can multiply, quotient law means I divide. If it was a nice question, we'd have something in the numerator and denominator cancel. Unfortunately, it's not that easy. So now we're here. Rewrite it in exponential form. Base of 4, exponent is 0, and all that fraction stuff is your answer. So 4 to the 0 equals all this stuff. And that's just converting it back to an exponential. 4 to the 0 is 1. Now we just have some algebra to take care of. So cross multiply, x plus 4 times 1 is just x plus 4 equals all that. Bring the x plus 4 over, they're going to become minus, and I'm going to do the binomial expansion here. So 0 equals, I'm assuming everyone knows how to FOIL and collect like terms. So we'd have x squared minus 4x plus 3. And when I bring over that x plus 4, it becomes minus x and then minus 4. Continue that up here. 0 equals x squared minus 5x and minus 1. Now, factor. That does not factor very nice. I cannot think of two whole numbers that multiply to -1 and add to -5. That does not mean it's impossible. I mean, it could be impossible, but it doesn't mean it's impossible. It means you got to go to your tried and true friend, Mr. Quadratic Formula. I'm not going to bother writing the whole formula down. I'm hoping most of you know it by now. But -b plus or minus b squared minus 4ac, all divided by 2a. Don't forget about the square root. My b is -5, becomes +5, right? Because it's -b, negative times negative is positive. B squared times 4ac is just going to become 25. I'm skipping steps here. It's just going to become 25 plus 4. 2 times a is just 2. That's going to be 5 plus or minus root 29 over 2. Which now we can split it into two solutions. 5 plus root 29 over 2. And x equals 5 minus root 29 over 2. If we go to two decimal places, 5 plus root 29 divided by 2, 5.19. 5 minus root 29 divided by 2, negative 0.19. Check both of those into your original question to make sure it works. 5.19 works here, works here, works here. We don't get any negatives. So that works. Negative 0.9. Already right off the bat in the first one, I get a negative. So not a solution. We would have log in base 4 of negative 1.19, and that would make us sad because we can't take the log of a negative number. Hopefully we don't find that too bad. Definitely had to recall some previous knowledge from grade 10 and grade 11. And that's a good question, actually. That's a very good question because it makes you use multiple laws of logarithms and the quadratic formula from previous courses. H. Still solving. They look weird. Treat them the same way. Base, exponent, answer. Base, exponent, answer. Okay, now we just repeat the process. Base, exponent, answer. Base, exponent, answer. 2 cubed is 8. So that was just one log hidden inside of another one. You just had to do the same thing twice. And again, that's not the only way to do these things. You could do it differently if you see a different way. Base, exponent, answer. Base, exponent, answer. How do you get rid of a 3/2? Well, you just raise both sides to the opposite, to the 2/3. 3's cancel, 2's cancel, right? It's just 1. And then that is the cube root of 64 squared. Going back to everybody's favorite unit on rational exponents from grade 11. And you can type that in your calculator. The cube root of 64 is 4 squared 16. Done. Our last example for solving, and this isn't a logarithm, this is an exponential like yesterday. However, I do want to go over this. And I don't typically go over this one. I usually leave it as like a challenge question, but I feel like I should show you, so that's why I've added it here. What looks different about this? Hopefully you're thinking this has a 2x and an x. So far we've only seen exponents that have like x's or like x plus 1, x plus 2, whatever, a binomial. We haven't seen anything that's like 2x. This actually is a quadratic exponential. Fun, right? And what you have to realize is that what you're looking at right now, and let's just do one thing first. Yeah, we'll do it. Let's bring that negative 6 over, becomes positive 6. So we have this. Oops, not the equal sign. We just said we wanted to write that as plus. So plus 6 equals 0. This does not equal. We're going to change the way it looks. So I'm going to write something off to the side here. Okay. Looks like. And I can't stress that enough. Because what I'm about to do, students are always like, how does that equal that? They don't equal each other. I'm going to make it look like something you're used to. This is a common tool in higher order mathematics, especially for those of you that perhaps take any university mathematics courses. Substitution. You could substitute anything for anything. So I'm going to make this look a little bit different. So I'm going to make this look like this. X squared minus 5x plus 6 equals 0. If I asked you to do that, you would factor that and you would get x minus 3, x minus 2, x equals 3, x equals 2. That's the exact same process we want to use on what we have on the left, that exponential. Now, if you're asking yourself, how is that on the left quadratic? Well, quadratic, remember, x squared just means something times itself. So, again, kind of doing another little aside here. X times x, something times itself. X squared, quadratic. Okay? If you did 3 to the x times 3 to the x, that's something times itself. Going back to your exponent laws from grade 10 and 11, when I multiply, I keep the base, add the exponents. What's x plus x? 2x. These two things are alike. Again, they don't equal each other, they're alike. So what that means is our x is like our 3 to the x. So there's a couple different ways you could do this. If you like the way that I have set this up to make it look like something, you can get to your final answer and realize, okay, I factored something that I recognize, but all along those x's have been 3 to the x's. So I'm going to go at the very end and make this a 3 to the x equals 3 and a 3 to the x equals 2. All you've done is a simple substitution. And I haven't written the step substitution. You would do that, in university, sub u equals 3 to the x, something like that, whatever. So we could get to there. So we get to this. Just by recognizing what's on the left is a quadratic. And again, it's quadratic because this times this, anything times itself, leads to this. Anything times itself is quadratic in terms of variables. Again, I can't stress it enough. What's on the left doesn't equal this. We're just changing the way it looks because we're comfortable with factoring that. However, if you don't like changing the way it looks to get to this step right here, you still have to realize this is like an x squared, this is like an x, there's my constant term. So instead of it writing as x minus 3, x minus 2, you have to realize this is 3x minus 3 and 3 to the x minus 2 equals 0. And if you FOILed that, you would get the exact same thing as your question. Now I'm looking for my zeros. 3 to the x minus 3 equals 0, which means 3 to the x equals 3. That one's pretty easy. X equals 1. 3 to the x minus 2 over here has got to equal to 0. That means 3 to the x has got to equal to 2. Take the log of both sides and power law. I'm going to cut to the chase here. So this would be x log 3 equals log 2. Divide both sides by log 3. X equals log 2 divided by log 3. If we go to 2 decimal places, what do we get here? We get 0.63, I believe. Let me double check that. Log 2 divided by log 3, 0.63. And again, you could double check your answers, put in 1, make sure you get negative 6, put in 0.63, make sure you get negative 6. If you made it look like an x squared, then you would have to again pick up at this step and realize that your x's were actually all along 3 to the x's. And you would do the exact same thing you just did here, here. Hopefully that makes sense. If you have any questions, there's not many questions like that. And like I said, this is typically more of a challenge question. I did want to show it to you though, just in case maybe it pops up in the review or different homework questions, or maybe it pops up as a bonus question maybe. We'll see. There's your work. Make sure you check D2L for the exact questions. And there are some review questions also to get ready for your test, which is on Wednesday afternoon. And hopefully, by the time you're watching this, we already know, or we've already been told if we're going to be back at HT or not. I've already mentioned to you that our plans for the most part aren't going to change regardless, but at least we'll know if we have to keep doing video lessons for the last unit or do some lessons in class. That's it. Thanks for listening. Talk soon.